So does anybody have any questions? Nate, you had a question. Number 4. Okay. So we want to find the missing term in this particular scenario. What we want to, there's a couple of ways you could do this. And let me show you the way that we've talked about yesterday, but I'm going to show you a different way. Okay. And the different method I'm going to show you is simply being shown to you to build those mathematical muscles. Okay? The first term is 8.1. The second term we don't know. The third term we don't know. The fourth term we don't know. But the fifth term is 240.1. And by the way, if this were a written response assignment or a written response exam question, you'd probably want to explain a lot more than what I'm going to say. Okay. For example, you'd probably want to write T1 here, T5 there. But the important idea here, Nate, is that to go from here to here involves multiplying by a common ratio. There's another way to do this one. Josh, you and I were talking a little while ago about another way to do this one. But I'm showing you a way to do it that will always work whether this is the first term or whether it's a different term. What I'm getting at, Nate and everyone, is that the common ratio in this question is going to be the same as it would be if that was the second term and 240.1 was the sixth term. Okay? It doesn't have to be the first term. And the reason, Josh, why what you did worked was that 8.1 is the first term. Okay, and I'll get to Josh's method in a second here. But that involves multiplying by r to go from the first to the second term. And we can continue that idea that to go from the second to the third involves multiplying by r, third to the fourth involves multiplying by r, fourth to the fifth involves multiplying by r. So to go from that term to the term that's labeled T5, or could be labeled T5, involves multiplying by r 4 times. Now that doesn't mean multiplying by 4r, it means multiplying by r. And if I were to write that out, multiply by r, multiply by r, multiply by r, multiply by r equals 240.1. This is r to the 4. That's the whole point of introducing you to powers at earlier grades, is it's a way to condense something like r. We write it as a base to an exponent, which is called a power. So now I have 8.1 equals 240.1. In order to solve this for r, and you know what, I didn't even really read the question, which is my fault sometimes as a teacher. But again, in order for you to answer anything about a sequence, you need to know the parameters that describe the sequence. And in this case, the parameters are the first term and the common ratio. And we know the first term. So what I'm doing here is I'm trying to find the common ratio. I'm going to divide both sides by 8.1. I'm going to get what I believe is going to be an awkward decimal, but then I'm going to convert it to a fraction and see what happens. Okay, I have a suspicion here about something. I told you yesterday, and I don't know if you remember because it was while you were working, I said, if you're given a question and they introduce the concept of decimals, feel free to roll with it and go with the decimals. But I have a feeling that if I take 240.1 and divide by 8.1, I get this goofy decimal, but I have a feeling as a fraction it's a nice fraction, and I'm going to qualify that and explain what I mean by that in a second. And I can't tell by looking at this what I believe is going to happen, but looking at what we have to do in the question, I suspect we get a fraction that's pretty good, 2401 over 81. That's not bad. So r to the 4 equals 2401 over 81. Now, In order for you to find out what r is, you have to take the fourth root. I know what the fourth root of 81 is. It's 3. Because 3 times 3 times 3 times 3 is 81. I don't know what the fourth root of 2401 is, but I suspect it's going to be a nice number. But maybe not. Excuse me. Let me back up. We have to take the fourth root. R will be equal to the fourth root of 2401 over 81. And there are some things in this course. Most of high school math is very sequential. You don't need to use something unless you've learned it already. There's something you kind of need to use here that you haven't really been taught formally. And that's that when you're talking about radicals, even that, you haven't been really taught much about radicals, but radicals are roots. When you have a radical of a fraction, you can take the radical of the numerator over the radical of the denominator. So when I use my calculator, and we need to know how to use the calculator here, to find the fourth root of 81, we get 3. Can everybody find the fourth root of 2401?
7.
Sorry?
7.
It is 7. So my suspicion was that even though the decimals were weird extended decimals, that when we converted it to a fraction, we would end up having numbers that were perfect powers of 4. Anyway, that's r. R is 7 over 3. Now, if we look at what it is we were asked to find, I think we're asked to find the common ratio and then maybe some missing terms, but let's confirm that. Well, it just says determine the missing terms, but you need to know the common ratio to do so. I know that to move forward, I multiply by the common ratio. To be honest here, I know I've given you permission to use decimals here, but 8.1 as a fraction is 81 tenths. And I would just challenge you to say that if I multiply by, we said r was 7 over 3. Is that right? Then I multiply the top of that fraction by 7 and the bottom by 3. And if I continue to multiply the top by 7 and the bottom by 3, I should get to 40.1 eventually. So 81 times 7 is 567 over 30. The reason why I'm saying, okay, we want to use fractions here, I've changed my mind, instead of saying you're allowed to use decimals, is I think even though this is a nice decimal and this is a nice decimal, I think these ones in between are not going to be very nice. Are they? They're all over the place. For example, 567 over 30. Well, that's not bad. But if I multiply by 7 over 3 again, oh, is it working out to be those kind of decimals? Well, then that surprises me. That really does. So you could either go fractions or decimals here, but I think I've answered the heart of your question, haven't I? Okay. Other questions? Go ahead.
5.
Okay, let's look at number 5. Determine a formula for the nth term. All you have to do here is identify the first term and the common ratio and put it into your general formula. So if I say to you, what is the nth term, and this is the general formula, your two parameters that define a geometric sequence are these two things. So whatever we get, pardon me, I've lost a little floating toolbar. I want to get it back. Give me a second. Smart. There we go. All right. Whatever we get for T1, whatever we get for T1, we're simply going to put here. Whatever we decide R is, we're simply going to put here. And that's it. And then we will be done. Because as we said yesterday, arithmetic general terms involve multiplying that common difference by the n minus 1 and doing all that algebra. But there's no algebra you can do here. You're not even allowed to multiply the first term by the common ratio because the common ratio is raised to an exponent. So in question A, Tn is going to be 3 times 2 to the n minus 1. In question B, T1 is 192. And then you have to figure out what R is. So what do you multiply 192 by to get negative 48 is one way you could reason it out. I believe it's negative a third. I think if you divide 192 by 3, you get 48. Or sorry, yeah, do you? It's 4, my mistake. It's negative 1/4. Or you could take negative 48 divided by 192. But the bottom line is it's negative 1/4. You just load those numbers into here, and that's the general term. T sub n equals 192, the first term, times the common ratio to the n minus 1. And because the common ratio is negative, you need to put in brackets the common ratio. When you look at C and D, well, we've already done the legwork for C and D when I did question 4. Okay, D actually is identical to question 4, that you're going to say I multiply 4 by the common ratio 12 times, But I had mentioned that Josh did something like D a little bit different. Since this is the first term, everybody, there's nothing wrong with you using this to find the common ratio. This will work. It won't work for C. It won't work for C. What you would do is you would say Tn equals the first term times r to the n minus 1, and then you would say that when n is 13, Tn is 16,384. You would put in a ordered pair to find the missing parameter. And what we would end up getting is 16,384 equals 4 multiplied by the common ratio, which we don't know, to the 13 minus 1. So when we divide both sides by 4, you get 4,196. I don't know. I think I have my hundreds wrong. What do you? Just 4096. Okay, thank you. Equals r to the 12, and now you have to take the 12th root of 4096. For some reason, I suspect it's going to be 2. Because I think 2 raised to the 12 gives you 4096. So r here is equal to the 12th root of 4096. Just quickly to remind you how that works on your calculator, you enter the number 4, or you enter the number 12, go to your math menu and choose xth root. It doesn't look right. That looks like 12 times something, but it isn't. And that will give you 2. Now you know the common ratio, so you can put in the common ratio in the first term. But notice, when you take a look at C, C cannot be done this way because you don't know the first term. C has to be done this way by talking about multiplying by something common ratio a number of times. So when you do C, and I'm not going to finish it, I'm just going to set it up for you. First term in C we don't know. Second term we don't know. Third term we do know. Fourth is unknown. Fifth is unknown. Sixth is 135. The formula cannot be used here. What you need to do is say times R, times R, times R. And that means that 5 times R cubed is 135. And then you can divide both sides by 5 and take the cube root. Anyway, any other questions? I did mention that there's another way to find the common ratio for something like C, and I would like to show it to you. And again, this is to build those mathematical skills. We know the following. When n is 3, Tn is 5. When n is 6, Tn is 135. Are you with me? That table is really crucial. We have this formula and would you agree that this and this are missing parameters? Yeah? How do you find missing parameters? This is maybe the 4th or 5th time I've asked this question, and sooner or later everybody's going to know. Paige? Right. You're going to load in ordered pairs. Now, by the way, sometimes you're only missing one parameter. And if you're missing one parameter, you just load in an ordered pair and you have that parameter. But if you have 2 missing parameters, you get exactly what Paige said. It's Paige, right? Okay. You get exactly what Paige said. You get a system of equation. Let's see what happens here. I put in for n in this equation 3. And I get coming out 5. When I put into this equation 6, what comes out is 135. Now I'm going to take 135 and put it up here. I'm going to write the second one above it. Are you with me? What did I write? Oh, wow. And you know why I wrote 5? Because I'm already one step ahead and I'm thinking I'm going to change that exponent to 5. Okay. Is that okay now? Thank you, sure. I want you to notice, and that's the next step, and I don't really feel like rewriting this whole thing. I want you to notice that what happens is that. We go from this to that. Now, I don't know if you remember this, but when we had arithmetic, what did we do with the 2 equations to get rid of T1? Do you remember? We subtracted them. Subtracting won't work here, but dividing will. And if I take 135 divided by 5, I believe I get 27. Is that right? And when I take T1 times r to the 5 divided by T1 times r squared, the T1s cancel and I'm left with r cubed. Because r to the 5 divided by r squared is r cubed. If you stop and think about how we did it without using an equation or a system of equations, we said that 5 had to be multiplied by r cubed to get 135 because they're separated by 3 pounces, 3 leapfrogs. When you solve that, you're going to have to take 135 divided by 5. Guess what you get? 27. So this is an algebraic way to do this. Now listen carefully. If I give you an assignment or an exam question where you have to show your work, if you do it by drawing the bunch of blanks and then putting the r's, times r, times r, times r, and building a single equation, you have to explain why that works. Okay? If you do it this way, you don't really have to explain anything because it's algebra. The whole thing is algebra. Anyway, we're going to move on now. Let's take a look at the next lesson, which is, I believe, on page 17 of your unit handout. And we are going to be looking at applications today. We're going to be doing a couple of other things. We're going to be solving some problems. Basically, I mean word problems when I'm talking about applications. And they can get a little tricky. And then we're also going to be looking at how is it you determine the number of terms in a sequence that's geometric. So we're just going to start off with examples. This says a rubber ball is dropped from a height of 4 meters and it bounces up to 3/4 of the height it falls from every time it bounces. So if we were to draw a picture, and you're going to have to decide what it is exactly you want to draw here. Here's the ball, and it's dropped from a height of 4 meters, and it's going to hit the ground, and it's going to bounce back up to a new height. And that new height will be 3/4 of the original height. So this original height is 4 meters. From the ground up to the ball. The ball falls, boing, hits the ground, it's going to bounce now. I want everybody to work out to what height it rebounds to. And it's not a difficult calculation because of the numbers we're using. Would you agree it bounces to 3 meters? 3/4 of 4. You can go 3 divided by 4, multiplied by 4 gives you 3. So it's going to rebound now to only 3 meters. So if I were to just look at the scale here, this is 0 and this is 4 at the top. 3 would be, I don't know, about here, approximately. So the ball bounces and it hits. But now the height is only 3 meters. And I hesitate in drawing anything else in this because it can get a little cluttered. But I'm going to do so anyway. This distance here is the 4 meters, and this distance here is the 3 meters. And then it's going to bounce to 3/4 of that. And I don't want to overcrowd our brains here and worry too much about fractions, so let's just go in decimals. Let's find out what 3/4 of 3 is. And that is not so easy to do in your head, but I think it's 2.25. So it's going to bounce again. And 2.25, this doesn't have to be drawn perfectly, but I don't want to do a lousy job. 2.25 might be about there, approximately. Maybe a little lower. So it rebounds again, and this is 2.25 meters. And I don't think we want to necessarily continue to draw this. I'm just drawing the first couple of bounces here to give you an idea of what's going on. Is there a relationship between these numbers, 4, 3, 2.25, and the number 3/4? Yes. If you take 4 and multiply by 3/4, you get 3. If you take 3 and multiply by 3/4, you get 2.25. What I'm getting at is these numbers are forming a geometric sequence with a common ratio of 3/4. Are you with me? 3/4 is 0.75. Now, if this says, what will the height be after 12 bounces? And I've seen people do this problem where they just make a table and they just keep calculating 3/4, 3/4, 3/4. They keep multiplying. That's not what we want to do. Because if that's all you can do, you're going to lose out later when we have to do this algebraically. But there's a problem here. Okay? It's a pretty serious problem, and I don't want you to write nothing else just yet until we resolve this problem. Would you agree that this is a geometric sequence with a common ratio of 3/4? It is. However, would you agree that this is the first term? Yeah? Well, that's a no-brainer. This is the second term. This is the third term. But here's the problem. The second term is the height it reaches after the first bounce. The second term is not the height it reaches after the second bounce. Look at the diagram. The second term, 3 meters, is the height it reaches after the first bounce. Okay? So if you set it up this way, and I'm asking you not to write anything down just yet. If you set it up this way, then the height after the, is it 12th that we're after? 12th bounce is T13. That's okay, you can do it that way. But wouldn't it be nicer if we had a sequence where the height after the 12th bounce would just be the 12th term? That would be easier. Well, rather than starting at 4, why don't we start at 3? If I ignore that 4 meters and I say the first term is 3 meters, and that's going to be the height after the first bounce, I'll get the answer. Quicker. Well, I don't know about quicker, with less thought. So now we're back to writing. There are 2 ways we can do this. Okay? One of the ways is to say T1 is 4, R is 0.75, and by the way, with a word problem, decimals are always okay. Okay? It's okay to get an answer in decimals. You don't want to say the height of the ball is some fraction of meters. And that would mean, just like question 5 that was asked about, we build a formula using the parameters. And the formula here, if we use T1 equals 4, which is the height after no bounces, our formula is going to be Tn equals 4 times 0.75 raised to the n minus 1. And we'll come back to that. If, however, we're a little more crafty about it and say, you know what, I'm not going to use that 4. So this sequence is 4, 3, 2.25, etc. This sequence is 3, 2.25, 1.675. Can somebody work out what 2.25 times 3/4 is for me? I'm wrong, I know that. 1.6, it's 1.6875. This is still geometric, but the first term is 3. The common ratio is 0.75. And again, I'm saying we're being craftier here because then n corresponds to the height after n bounces. If I use n equals 12, I'll get the height after the 12th bounce. So my formula this time is going to be T sub n equals 3 times 0.75 raised to the n minus 1. Okay? But again, these are different because the height after the 12th bounce will be T13 here, but the height after the 12th bounce here will be T12. That's tricky. Your textbook likes to go with this on the left, which I don't understand that. It requires more thought. I do want you to notice something, though. Here, we're trying to find that. We're going to put n equals 13 in and calculate it. Here, we're trying to find that. What happens when we put 13 in here? We get 4 times 0.75 to the 13 minus 1. On the right, we get 4, no we don't, we get 3 times 0.75 to the 12 minus 1. So this is 4 times 0.75 to the 12, because 13 minus 1 is 12. And this is 3 times 0.75 to the 11, because 12 minus 1 is 11. How many of you see those are the same thing without even calculating them? Because that 3 in the right-hand equation is 4 times 0.75. So there's one of your 0.75s that you're already using, and then there's 11 more. It doesn't matter which one you do, you will get the correct answer. But just to make sure you're with me on this, it's the discrepancy between these two numbers that can cause a problem. Whereas if I set it up with the equation on the right, there's no discrepancy. In either way, no matter which way you do it, I'll go 3 times 0.75 raised to the 12. I use this little roof button, and I get 9.5 centimeters. Yep.
You're supposed to raise it to 11.
Did I enter the wrong exponent? Thank you. Oh, yeah, I should have looked at what I had written on the board. Times 0.75 raised to the 11. Thank you. So I get about 0.127 meters, or about 12.7 centimeters if you wanted to do a conversion there. If I use the equation on the right, that's what I get. If I use the one on the left, 4 times 0.75 raised to the 12 gives me the same answer. So regardless, that's the answer. Let's take a look at another example dealing with an application. When you get asphalt shingles put on a roof, the asphalt is a tar base, and there's a granular stuff on it. If you've ever cleaned out eaves, you get a whole bunch of that granular stuff collecting in the eaves. All the freezing and melting and rain that's hitting the shingles, especially the freezing and melting, wears down the shingles. And we've all seen roofs that have shingles that are really starting to curl, and there's not a lot of coating left. It turns out that there's a relationship here between how long the shingles are exposed to our climate and what percentage of asphalt you have left. So when you first get shingles manufactured, they have what we call 100% asphalt coverage. They're perfect. Perfect amount of asphalt. But they lose 4% every year. Okay? About. Depends on the shingles, but about 4%. Determine the percentage of asphalt remaining after 6 years. Okay, so we're going to have the same issue, I believe, here as we had with the bouncing ball. If I say that this is the amount of asphalt we have to begin with, 100%, and I lose 4%, I hope it's obvious that you have 96% left. But when I say I lose 4%, that doesn't mean I'm going to have 92% next time. I'm going to lose 4% of 96. If I go back to the 100, 4% of 100 is 4. When I take 4 away from 100, I get 96. Right? Here's the calculation. You don't need to do this, but 4% of 100. This is after the first year. 4% of 100 means 4 over 100 times 100. 4% of 100 is 4. So I subtract 4, right, to get 96. What will be the percentage remaining for the next term? Well, I have to take 4% of 96. Well, that's 4 over 100 times 96. Figure it out for me, please.
92.16.
I just want to know what 4% of 96 is first. 3.84. So this is 3.84. We lose 3.84. So we're losing 4%, we're losing 3.84%, and when you do that, you get 92.16.
Yeah.
Okay. I'm going to do just one more with you, and I'll do it on the calculator. I'm going to take that 92.16, I'm going to find out what 4% of it is, which is multiplying by 4 over 100. And I'm going to take this number away from 92.16. $88.4736. Did I record the number correctly?
Yeah.
I want you to decide whether this is geometric or not. Because it may not be entirely clear based on our calculations what's going on. The only way you can decide if it's geometric is to ask yourself, what do I multiply the first term by to get the second term? And if I multiply the second term by that number, does it give me the third? And if I multiply the third by that number, does it give me the fourth? And what I'm leading up to here is a very, very important idea for Math 30-1. Don't forget the common ratio is found by taking a term and dividing by the term before it. Aoki, what do you get if you take 96 divided by 100? 0.96. What do you get if you take 92.16 divided by 96? 0.96. Wait a minute, why? This is the important thing. Why is it that the common ratio is 0.96? There's a reason. There is a reason. Anybody want to take a stab at trying to explain why we have to multiply by 0.96 moving forward? Paige.
Because 1 would be like 100%, so it's 4 less than that.
Right, we're losing 4%. No matter what you start off with, you can think of that as 1 or 100% of what you're starting off with. If you lose 4%, then you keep 96%. It's like me saying we're going to have 4% off for a sales price. You can either find out what 4% of that item is and subtract it from the item, or just say, if I lose 4%, I keep 96%. So the thinking here is 1 is like 100%. We're subtracting 4%, which is 0.04. Just briefly here, and it isn't important for this question, but if I had a population of people or bugs or whatever that was increasing by 4% regularly, the common ratio would be this. Would be 100% plus that 4%. But if we're losing 4%, then it's 100% minus 4%. And percent means divided by 100. By the way, 100% plus 4% equals 104%. But percent means divide by 100. So if you take 104 over 100, you get 1.04. Over here, we're getting to the question. We're going to get back to the question in a second, but this is fairly important. We're losing 4%. That gives us 96%. Percent means divided by 100. So 96 divided by 100 is what we get to keep, which is 0.96. So this is a geometric sequence, yes? However, I shouldn't have done that. However, in this geometric sequence that we're talking about, I can get rid of this. This is T1, correct? But T1 is not the percentage of asphalt left after 1 year. T1 is the amount of asphalt you have at the beginning of the year. This, T2, is the amount remaining after 1 year. So we have the exact same issue that we had with the previous question. If you want to use this, if you want to use T1 equals 100 and R equals 0.96, then the amount remaining after 6 years is going to be T7. Because it's the second term that tells you about the first year. The third term will tell you about the second year. The seventh term will tell you about the 6th year. So why not do this instead? You can choose to explain this to yourself in your notes however you like. Yes, David? Of course. I'm just going to explain it by saying if we look at those terms, then T1 is 96%. The common ratio is still 0.96, and I'm going to be after the 6th term because I've set it up so the first term is how much is left after 1 year, the second term is how much is left after 2 years. I'm being consistent. N in the sequence goes with the year number. I'm not going to do both calculations. I'm only going to do the one here. My general term is Tn equals 96 times 0.96 to the n minus 1. So to answer this question, I put in 6. If you did it over here, I said I wasn't going to do it, but I guess I will. This is the equation. But since you're finding T7, you're going to use n equals 7. If you did it this way, and I don't like doing it this way. By the way, if I give you this on an exam, we'll get to the answer in a second. If I give you this on an exam, I'm not going to force you to pick one or the other. The question is going to be, how much is left after 6 years? And whichever way you do it, you have to get the right answer. I'm just going to do it with T6, 96 times 0.96 raised to the 6 minus 1. Go ahead and have adder on your calculator. You're going to have to take 96 times 0.96 raised to the 5. Because 6 minus 1 is 5. About 78.3% remaining. All right. When you have these geometric problems, a lot of the time you have to think about whether the term number is going to match what you're after or not, and a lot of the time it won't. And it's very easy to look at, say, the previous question and set it up and go, well, if I want to find the height after 12 bounces, I'm going to use this sequence and find T12, but that's going to be wrong. T12 will be the height after 11 bounces. If you quickly read this next question without thinking, you might say, well, here's the sequence, 196. I'm going to find T6, but that's wrong, because T6 is not the amount after 6 years. It's the amount after 5, if you use 100 as T1. One more question related to question 2. The shingles need to be replaced when the asphalt drops below 45%. How many years are the shingles good for? So what this question is basically asking is this. I have Tn equals 96 times 0.96 to the n minus 1. That's my preference. That way n in the formula matches the year number. What the question is asking is this. It's a little more complicated than what I'm writing here, but that's what it's asking. So we would put 45 in for Tn and ask ourselves, well, let's rearrange this for n. Well, I mean, I could have a little bit of a laugh. It wouldn't be a really funny laugh, but I could say, okay, I'll give you guys 5 minutes to solve that algebraically. The laugh is that you can't solve it algebraically. You don't know how. It's possible using logarithms, but you don't know about logarithms yet. You won't know about that till next year. So what we're going to do, and this is what makes geometric applications actually quite easy, we're going to use our graphing calculator. We're not going to graph. We're going to create a table. We're going to create this table in the table of the calculator. And correct me if I'm wrong. I've shown you how to set up a table before, right? Just once, I think. But some of you don't remember, and I get that, because we've only done it once, maybe twice. What I'm going to do, let's forget about the 45. Let's put this expression that's to the right of the calculator or into y1. Now, I have a whole bunch of stuff here from my Math 30-1 class. So clear out all of your y's. And we don't have access to an n key. We use x instead. I know that when you look at this x key, there's an n there, but that's something different. We could go that route, but it's more confusing than it needs to be. Now, why will what I've just entered not work? What's wrong with how I've entered that? Yeah.
The x minus 1 needs to be in brackets.
Exactly. What this is, and I just want to make sure you understand this, what I've just told the calculator is 96 times 0.96 raised to the x minus 1. That's what I've just told the calculator to do. I need to put that x minus 1 in brackets. All right. Now, again, we're not going to graph it. We want to go to our table, but the table can be set up in a number of different ways, and I've been working with my table in other classes for other things. When you set up your table, now I have to wait for it. you go to the part of your calculator that says table set, and it's second window. There we go. So where you are going to go is here to set up the table. And there are basically two modes in setting up the table. One is the mode I have it in right now, where it says independent, ask is highlighted. I don't want that. I want it to automatically generate a table of values, so I make sure this is auto. There is never any reason why you would change the dependent. Okay? And I want to start at 1. What this is telling me, when I go table start 1, is the first value it's going to generate will be calculated using x equals 1, which means I'll be finding the first term. This is supposed to be a triangle. And a triangle in math and science means delta. It's a Greek letter called delta, and it means change in. So what is the change in x that we want? Well, I want to start at 1 and go up by 1. This is going to generate a table where x is 1, and then 2, and then 3, and then 4. If I did this, it would generate a table where x is 1, and then 3, and then 5, and then 7. It would go up by 2 each time. So I'm going to go up by 1 each time. And what I'm going to generate is this sequence of numbers that I've highlighted. So when I go to my table, which is second graph, I have those numbers. I've created my NTN table. So if I were to ask you, we're looking at question B here, everybody. After 7 years, are the shingles still good? Yes. After 8, 9, 10, 11, 12, 13, 14, after 15 years, are they still good? No. They're only bad if they drop below 45. 16, 17, 18, 19. Are they good after 20 years? No. So for how many years are they good? 19. We have to round down here. We can't say, well, it's 20 where they fall below. Listen, if you bought these shingles and you waited 20 years, there would be part of that 20th year where they're not good enough. Trust me, you wouldn't get water coming in. You wouldn't. But you might get heat damage in your attic because shingles do more than just prevent water from entering your house. They act as an insulator between your attic and the outside. There's a moisture issue here. So the answer is 19 years. So these would be shingles that would probably be advertised by the manufacturer as being 20-year guarantee. But after 20 years, definitely they're not going to, you're on your own. So the correct answer mathematically, though, is 19 years. The nice thing about the geometric is because you don't really understand the math involved in finding exponents, you just use your calculator. By the way, if you didn't want to scroll and you go to your table setup, you can change independent, which is X, to ask. Go to your table and say, well, I don't know, are they good for 25 years? Definitely not. What about 22 years? No. 21 years? No. 18? Yes. What about 19? Yes. What about 20? No. The ask thing means you're allowed to input different values of n or x. Any questions with that example? Yeah.
If we were to use this method on a written response type question, how would we show the work?
I would never, it's a great question. How would you show the work on a written response? I would never give you this on a written response. Because the purpose of written response is for me to find out if you understand how to show me the work. So anything that can only be done on your calculator would be a numerical response. This would be a great numerical response question. Just even forgetting about A, me telling you about the properties of the shingles, that they lose 4% every year, for how many complete years are the shingles still good? Numerical response. You have to come up with the equation, throw it into your calculator, and then use your calculator to find n. Have I answered your question, though?
Yes.
Yeah. And similarly, you're actually going to get your first written response assignment today that deals with arithmetic and geometric sequences. There will be nothing on that assignment that asks you to find n for geometric. But of course, you do know how to find n for arithmetic algebraically, because you can rearrange that Tn formula. Tn equals T1 plus n minus 1 times d. You can rearrange that for n. Okay. All right, let's move on. I believe we just have one more example. Yes. How many terms are in this sequence? Well, what this boils down to in principle, it's a very simple question. But what it boils down to in principle is the same thing it boiled down to for an arithmetic sequence. This table, I really believe, is very helpful in getting people to understand not necessarily the math, but what needs to be done. The first term is 4096. The second term is 6144. The third term is 9216. And the last term is 531,441. Can you double check my transcription of those terms? Did I write them all down correctly? Okay. What the question is this. What's n? What value of n gives you that last term? Because, and I've used this analogy before, I'm just guessing, if it's right, it's a wild guess. If the value of n that gives you the last term is 12, then the number of terms has to be 12 because that is the last term, and if that's n equals 12, there's only 12 terms in the list. All right, well, we can build our general formula just like example 5 or question 5 from the homework that was asked about. How do you get, that's wrong, how do you get the general term? You throw in the common ratio and the first term, the two parameters, you put them into this formula. Well, I mean, the first term is 4096. The common ratio is just a matter of me asking, what is it I multiply 4096 by to get 6144? Or what do I multiply 6144 by to get 9216? And I wouldn't expect anybody to see the answer. You're going to have to go backwards. 6144 divided by 4096. I want to say 3 over 2. No? 1.5? Okay. And, you know, since we're going to do this on our calculator, who cares if we write 3 over 2 or 1.5? This is a multiple choice numerical response kind of thing. Now, in Math 30, you can do it algebraically, but I wouldn't ask you this question in Math 30. It would be a different question. But you will, in Math 30, study what are called exponential functions. And what's going to happen is, in Math 30, we'll just say, well, this is exponential. Geometric and exponential mean the same thing. Remember that penny doubling? That's exponential. So I put in the first term, 4096, multiplied by the common ratio of 1.5. I think we have permission to just go 1.5 to the n minus 1. Well, put this in your calculator for y1 and find out what value of n, which will be x, gives you 531,441. And you know, to be fair, if you get the exam sweats, we've all been there, where like you start panicking in an exam and you forget about the table thing, you could just start putting n's in here and in your calculator here until you get that number. Like you could say maybe n is 12 and you could put 12 in and calculate it. I just think this is more efficient. 4096 times 1.5 raised to, I don't need brackets around r unless it's negative. But I do need brackets around the x minus 1. Go to my table. Oh, I'm on ask mode. So I could put in maybe 12. I tried 12 before. Is that bigger or smaller? That's not quite there. I think it must be 13. So you could do that. Yeah. Or you could set it up, start at 1 and go up by 1 automatically. I think many of you will see, looking at the size of the number, it might be quicker to start at 8 or 9 and go up by 1. But you can always scroll. We want it to be 531441. There it is. So it's the 13th term. I was off by 1. Remember I guessed 12? It's actually the 13th term. So there are 13 terms in the sequence. That's the answer to the question. Numerical response, most likely. And I wouldn't even give you this as multiple choice, because then you could just start putting in the answers and checking them, which is trivial. It's a grade 6 way of doing a multiple choice question. Okay, that's going to be the assignment. Before I get you started on the assignment, let me speak to the hand-in assignment that you're going to be getting. And I don't want to give it to you right now. I want to talk to you about it first. The first thing to note is that anytime I give written response assignments in this class, they're all different. Your assignment is different than your assignment. There are 34 different versions of this assignment. Okay? And what that prevents people from doing is simply copying. So this is version 3. I've broken it into question 1 and question 2. This one is question 1 and 2, but it's version 4. So you know when we do written response in exams, it will always be one question, A and B. I've broken this into 1 and 2. But one of the questions will be worth 3 marks and one will be worth 2. This first part is worth 3. There's 2 marks there, and there's 1 mark here. The second part is worth 2 marks. So these are always marked out of 5. What I expect you to do is show all of your work in a clear manner, in a complete manner, and in an organized manner. If I get turned in to me something with arrows all over the place, go through this tunnel to get to that number and do that, it becomes confusing for me to mark, and part of your mark is your ability to communicate effectively mathematically. It is. So things need to be organized. When you see the word algebraically, that has a very specific meaning in high school math. It means using symbolic language and equations. It does not mean, for example, figuring out in your head what the answer is and then going, 12 plus this number plus this number plus this number will give me negative 42. That's not an algebraic approach. An algebraic approach is writing out an equation. If it's an equation, by the way, everybody, that comes off of your formula sheet, you can just go with it. If it's an equation that you build, you need to explain it. So, for example, if I built an equation that said T5 plus 3D equals T8, I don't care whether that's true or not. I need to explain it. I need an explanation as to why I'm saying the 5th term plus 3 common differences is the 8th term. And an explanation means words. Words can be accessorized with pictures, but we need words. And I would always accessorize my explanation with pictures if it's possible. All work needs to be shown at all times. That means if you're rearranging an equation, I need to see the steps in rearranging it. I want to make sure that I don't, there are no surprises here. If you end up at some point trying to solve this equation, I know and you know that it's very easy to solve that. You take negative 220, you subtract 22 and divide by 4. And in fact, in class, I will say that to you. Oh, it's really simple. You just do that. But on a written response, you need to show those steps. You need to write minus 22, new equation, divided by 4, then you have your x equals. By the time you get to math 30, some of those things do not need to be shown. Like, if you had x minus 4 equals 0, I don't think you would need to show that you're adding 4 to both sides. You could just say x equals 4. But we're not in math 30 yet. So you need to show work. You need to explain when it says explain. And in all these questions, there will be, we call them guiding words. They're bold. Determine, algebraically. Explain. Determine. Algebraically determine. Explain. Now the last thing I want to say to you is, for number 2, it says express your answers in decimal form rounded to 3 decimal places. Okay? That's only for question 2. You're always in high school math for answers wanting to put exact values, if need be, in fractional form. And the only time you're allowed to use decimals is if you're given permission. And you're given permission in number 2. Do you get the general idea of what the level of my expectations are for this? All right. This is due at the beginning of class on Tuesday, February 14th. Beginning. So when the bell rings and I say turn it in, it needs to be done. Okay. It's due at that time regardless of whether you're in school that day or not. So if you are absent, you need to take a picture of both sides of this and email it to me. Okay? That's the expectation, that assignments are due when they're due. And lastly, I know you're probably very excited about Teachers' Convention. I can guarantee you we're all more excited about Teachers' Convention than I am. But I remember being a student and being excited about it and making the mistake sometimes of taking my books home, throwing them in the wherever, on the couch in my room or whatever, and then forgetting about everything, and then waking up after going to bed Sunday evening, waking up in a cold sweat going, oh, I got that thing due tomorrow. Don't do that. Take this home. I think you should work on it this weekend, because if you leave it till Monday night, you won't have the opportunity to ask me questions for clarification, right? Anyway, I'm going to hand that out to you in just a few minutes, and in the meantime, you can get started on these questions. You still have about 15 to 20 minutes left in class before the bell. Get started, please, and I'll be around to help you. Of course.